I'm going to solve this problem use a typical approach. Then later on, in a separate video, I'm going to show you the shortcut. Make sure you understand the two approaches. One standard approach, the other is a shortcut. So the covariance, by definition, means the mean of the product minus the product of each mean. Okay, and so the first term is do an integral over basically your xy, fxy dx dy over the 2D plane. Your 2D plane is here, we're going to figure out later, minus your mean of x is a 2D plane integral x fxy dx dy times dy, the same thing, 2D plane, your y fxy dx dy. Okay, so once you settle the formula, all the rest of the details, you figure out the do the integral here. Let's figure out the constant k. The integral here, the origin here, your x is from 0 to 1, and y is from 0 to 1. Basically, a unit square here. Okay, unit square, and so we need to find out the k. Do the setup using the requirement, your total probability needs to be 1. So doing the integral here, this is your 2D, let's call it D, the 2D plane here. So doing the 2D plane, your fx dx dy ought to be 1. So we're going to set up the integral here. Your x is from 0 to 1. This is dx. Your y is also from 0 to 1, right? So dy, this is your joint density kx. Okay, this is if you do this integral here, you should be able to get this final result of 1/2 k. That ought to be 1, so your k is 2. Okay, that's kind of first step. And once you figure that out, all the rest, you just do more integrals here. For example, let's do this integral here. The first term is just integral, right? Your x is from 0 to 1 dx. The inner integral is y. Your y is from 0 to 1 as well. Okay, and then you have this sort of x and y times the joint density. Joint density is 2x, right? Times 2x. So this is kind of first integral you will do, and that will give you. You can do this yourself. You can get that's actually is 1/3. Okay. Similarly, you can do the integral ex. Your ex equals integral x from 0 to 1. Same thing. Same integral. Okay. dy. Your y is from 0 to 1. Now the only thing here is different. Here is x times 2x. Okay, and you can do the integral on your own here. You can get your ex is just 2/3. And similarly, you can do the integral here. Set up similar integral for ey here. Okay, ey is your x from 0 to 1 dx. Your y is from 0 to 1 dy. So your y times 2x. Okay, you can do this again. The integral is 1/2. So the covariance becomes the exy, which is 1/3, times ex 2/3, times ey is 1/2, equals 0. So your covariance is 0. That's kind of standard approach on how to solve this problem. Next movie I'm going to show you the shortcut.